Hello everybody, it's Dumplet here. Here's an item on geometry. Rectangle ABCD is drawn such that AB equals 7 and BC equals 4. BDEF is a square that contains vertex C in its interior. Find CE squared plus CF squared. As usual, pause this video if you'd like to give this item a try. But if you're done, let us dive into the solution. Now, there are numerous ways to approach this item. The first thing that I actually thought of is this. So since we have this figure, I can label some angles. I have alpha here. Let angle FBC here be alpha. And since we have a square here, we can label the complement of alpha to be beta. So this is beta, and we have a rectangle over here, so we have a right angle here at all the angles. So BCD here is a right triangle, so we know that this angle would be alpha since A and B are complementary, and as a result, this angle over here would be beta. Now, we already have the lengths of BC and CD to be 4 and 7, and in fact, we can get the lengths of BF and DE. So the length of BF and DE, which is just the side length of the square, we can easily get the side length of the square just via Pythagorean, since we have a right triangle BCD over here. Now, one can easily get that S squared should be equal to 4 squared plus 7 squared. And, just get the square root so you can get the side length. And we can apply cosine law in triangles FBC and triangle CDE, so we can get CF squared and CE squared. And indeed, this is a viable solution. However, Dumplet here would like to show you an alternative solution that involves some cute geometrical setup, and you'll see in the next figure that I'll be showing. So we have this figure over here. So all I did is just construct 4 right triangles. So 1, 2, 3, and then 4. Now, all of these 4 should be congruent with legs 4 and 7 over here. Now, this will result in a square in the middle. We can prove it to be a square. So since everything has all of the right triangles have legs 4 and 7. So this part would be 7. However, this part, which is part of another right triangle, has a length of 4. So this part must be 3 then. So 3 is 7 minus 4. And this will apply to all the sides of the square. Hence, we have a square in the middle. So we know that the square in the middle has a side length of 3. Now, going back to the item, we want to get CF squared and CE squared. Now, what's interesting is that CF is part of this right triangle over here, and CE is part of this right triangle over here. So we can easily acquire the values via the Pythagorean theorem. In fact, let's start with CF squared. So we know that CF squared would be equal to 4 squared over here plus 3 squared over here. Now, in this right triangle, we can get CE squared. So CE squared would give us 3 squared plus 7 squared. So CE squared would be 3 squared plus 7 squared. So we would acquire these two equations for CF squared and CE squared. So all we have to do is just evaluate this, and 3 squared plus 7 squared evaluates to 9 plus 49. This gives us 58. 3 squared plus 4 squared evaluates to 9 plus 16, which is 25. So all we have to do is just add the two. So CE squared plus CF squared equals 58 plus 25, and we'll arrive at our final answer of 83. So this is technically just an alternative way to the regular cosine law that you apply. Now, if you go back to the figure, this is a very famous figure actually. It's actually used to prove, one of the ways to prove the Pythagorean theorem. So this setup, if it appears in some of the math questions in geometry, then at least now you guys will know that it's just 4 right triangles and a square in the middle. So Pythagorean is usually used to solve items like this, but anyway, whatever method we use, we should arrive at our answer of 83. So hopefully you guys learned something new from this video, and I'll see you in the next one. Bye bye!